Okay, so let's get started with the Developmental Math 1 Final Exam Review. Okay, number 1, simplify. So we have 3 plus 18 divided by 6 plus 9 times 3 squared. So when we are solving or we're simplifying an expression, we want to always use order of operations. And then the way that we like to remember that is what we call PEMDAS. So P represents parentheses or grouping symbols. E represents exponents. M and D represents multiplication and division. And then A and then S represents addition and subtraction. So let me just make a note. This is also the grouping symbols. Alright, so remember that for multiplication, division, and then addition and subtraction, we do whatever comes first from left to right. Looking at this, 3 plus 18 divided by 6 plus 9 times 3 squared. So we don't have any grouping symbols. Next, we're going to look at exponents. So we do have an exponent here of 3 squared. So 3 squared equals 3 times 3, which is 9. So we're going to write that 9 and write everything else down. So now we have 3 plus 18 divided by 6 plus 9 times 9. So now we've taken care of our exponents. Let's look and see if we have any multiplication or division. And we do have both. We have multiplication and division. But like what I have here in the red, you do what comes first from left to right. So that means we're going to do 18 divided by 6, which is 3. And then we have 9 times 9, which is 81. And then we're going to bring down that 3 plus that positive 3 plus 81. So now we have only addition. So now we're going to add these three numbers together. So I'm going to write that vertically. 81 plus 3 plus 3. So 1 plus 3 plus 3 would be 7, and then bring down that 8. So the final answer is 87. Okay, number 2, simplify. 4 squared minus 3 squared divided by parentheses 4 minus 3 squared. All right, so now we do have grouping symbols that we want to simplify and work within first. So we're going to work in the parentheses first. And so we have 4 minus 3, which of course is 1. So we have 1 squared at the bottom, and then we have 4 squared minus 3 squared at the top in the numerator. And so now we want to take care of all of our exponents. So we have 4 squared. So 4 squared is 4 times 4, which is 16, minus 3 squared is 3 times 3, which is 9, divided by 1 squared, which is 1 times 1, equals 1. And so now we have 16 minus 9. Well, it's at the numerator. So 16 minus 9 equals 7, because 7 plus 9 is 16, divided by 1. And 7 divided by 1 equals 7. So the final answer here would be 7. Okay, number 3. Determine the prime factorization of 154. So the way that I like to start to find the prime factorization is to do a factor tree. So what a prime factorization is that we're going to write out the product of only powers of prime numbers that will equal up to give us 154. So we're going to start with 154. And I want to think of two numbers that will multiply together to give me 154. And right now I don't know, really, it's kind of a big number, right? But it is an even number. So since it's even, I definitely know that 2 is a factor of 154. 2 times something equals 154. And the way that I can figure that out is to divide 2 into 154 and see what I get. So 2 can divide into 15 7 times, because 7 times 2 equals 14. And then when I subtract, I get 1 and then bring down that 4. And then I'm going to say 7 divides into 14 7 times. 7 times 2 is 14 with a remainder of 0. Because like I said, I knew that 2 divides evenly into 154 because 2 is a factor of 154. So therefore, when I divide 2 into 154, I will get a 0 remainder. So this tells me that 2 times 77 equals 154. Well, 2 is a prime number. 2 cannot be divided by any number other than 2 and the number 1. But 77 has more factors other than 77 and 1. Since it's 77, I know that 11 is a factor of 77 because 7 times 11 will give me 77. So now I have 7. There's no other numbers that can divide into 7 other than 7 and 1. Same as 11. There's no other numbers that can divide into 11 other than 11 and 1. So 2, 7, and 11 are all prime numbers. And so what this tells us is that 2 times 7 times 11 will equal 154. And so this is our prime factorization of 154. Now notice it's a prime factorization because 2, 7, and 11 are all prime numbers. Just a regular factorization would just be, say, 2 times 77, because that also equals 154. Another factorization could be 1 times 154, because that equals 154. But a prime factorization needs to only be a product of prime numbers that equals 154. Okay, number 4, graph x is greater than or equal to -1. So we're going to graph that on a number line. So here's my number line, and I'm going to plot -1, and then I'm going to write some numbers on the right and left side of -1. So if we have a negative number of -1, 0 is going to be to the right of it because that is greater than -1. All values greater than a number are going to be to the right of it on a number line, and then all the values less than it on the number line are going to be to the left of it. So this is kind of how we can write out our number line. So to graph x is greater than or equal to -1. Well, first off, let's remember our symbols. So we have greater than or equal to, and then less than or equal to. So these are going to use closed dot. Greater than or less than are going to be open dot. So since this is greater than or equal to, I'm going to use a closed dot over -1. And so now x is greater than. So where are all the values greater than -1? To the right. So I'm going to shade everything to the right. And this is how the graph should look. On the final, I think it may be multiple choice, so you may get like 4 different graphs, and you have to pick the right one. So things to pay attention to would be whether it's an open or closed circle, and whether it is being shaded in the right direction. These are all things to kind of pay attention to when you are answering that question. Number 5, compare -11 and -5. This is kind of similar to what I was just talking about with the number line. So if you think about a number line, so if we had 5 and 11, then +5 would be to the left of +11, right? Which would mean that +5 would be less than +11. But we have -11 and -5. So remember that on a number line, let's say we have 5 over here. Well, less than 5 would be 0, and then less than 0 would be -5. So that means that less than negative 5 would be negative 11. All right? So this tells us that negative 11 is less than negative 5. So don't let the negative signs throw you off when you are comparing integers. Okay? That's kind of the main point with this problem here. Okay. Number 6, simplify negative 5 minus negative 7. So when you are subtracting integers, you can change them to an addition problem by adding the opposite. So here we'll keep the first one the same, negative 5, and then we're going to change the subtraction to addition, and then make the negative 7 opposite, so that would be a positive 7. So now we have adding integers. So when you add integers and you have different signs, you're going to subtract and take the sign of the highest or the biggest number. So in this case, 7 is bigger than 5, so it's going to be a positive answer. And then we are going to find the difference or subtract 7 and 5. And so that would be 2, so the answer is positive 2. I can also show you on a number line. So let's say we have a number line here. I'm going to plot negative 5. So this would be negative 4, negative 3, negative 2. So negative 5. Here's negative 5 right here. And then plus 7. So negative 5 plus 7. So let's go 7 to the right. 1, 2, 3, 4, 5, 6, 7. And there we are at positive 2. Okay? All right. Number 7, simplify 6 divided by negative 3. So this says 6 over negative 3. That's the same thing as saying 6 divided by negative 3. So when we multiply or divide by a negative number, we're going to get a negative answer. So 6 divided by 3 equals 2. So since it's 6 divided by negative 3, that's going to equal negative 2. When we multiply or divide, same signs, it's going to be positive answer. If we multiply or divide different signs, it's going to be a negative answer. And those are the basic rules for multiplying and dividing integers. All right, number 8. Simplify 9 divided by 3 times 4 minus 5 plus 2. Let's recall order of operations. So we do not have any parentheses that we need to work within. We don't have any exponents, so we do have multiplication or division. So let's see. We do it first from left to right, multiplication and division. So that means we are going to take care of this 9 divided by 3, which is 3. Bring down times 4 minus 5 plus 2. And then I'm going to take care of this multiplication. 3 times 4 is 12. And then bring down minus 5 plus 2. And then now I just have addition and subtraction. And you do what comes first from left to right. So we have 12 minus 5, which is 7. Bring down that plus 2. And then 7 plus 2 equals 9. Number 9, simplify the absolute value of negative 126. This is an absolute value problem. So remember that the absolute value of a number is basically the distance that number is from 0. And remember that distance can never be a negative number. So the absolute value of negative 126 is positive 126. Now I want to show you some examples. So let's say we had another example. Negative the absolute value of negative 126. Okay? So first work within the absolute value. So we just did that before. So the absolute value of negative 126 is positive 126. But I still have this negative on the outside. So the answer is actually going to be negative 126. I just wanted to show you the difference between the problem number 9 and then another example down here, because students often get those two confused. Okay, number 10. Simplify 9 times negative 6 plus 10 plus 3 times negative 2 plus 5. So we can use our order of operations to solve this problem or simplify it. So we're going to work within the parentheses first. So I have negative 6 plus 10. So I have different signs. So I'm going to subtract 10 minus 6 and take the sign of the larger number, which is 10. So I'm going to get a positive 4. Then same thing here. I have different signs, negative 2 plus 5. So I'm going to subtract and take the sign of the larger number. So 5 minus 2 is 3. It's going to be a positive 3. So I have 9 times 4 plus 3 times 3. Next, I don't have any exponents, but I do have some multiplication that I want to simplify. So 9 times 4 is 36. Definitely be familiar with your multiplication table. And then 3 times 3 is 9. So I have 36 plus 9. And then now I'm going to add that vertically. So I'm going to line it up like this. 6 plus 9 is 15. Carry the 1. 1 plus 3 is 4. So the final answer will be 45. Okay, number 11. Simplify negative 3 to the third power. So this is an exponent. So negative 3 is your base, and the 3 here is your power. And what negative 3 to the third power means is that I'm taking negative 3 and I'm multiplying it 3 times. Okay? So now let's simplify this. So let's work from the left to the right. So negative 3 times negative 3. Well, a negative times a negative is a positive, and 3 times 3 is 9. Sorry. And then now I have 9 times negative 3. And so 9 times negative 3, so I'm multiplying different signs. So I'm going to have a negative, and then 9 times 3 is 27. So the final answer is going to be negative 27. Okay, number 12. Round 0.75 to the nearest tenth. I'm going to write that bigger because I write big. So the 10th place is where the 7 is. That's the 10th place. So in order to round this, we must look at the number to the right. So if this number in green was 0 through 4, we would stay the same. So the 10th, the number 7 would stay the same. If it was 5 through 9, we're going to round up. We're rounding the 10th place, which is where the 7 is. We look at the number to the right. That number is number 5, so we are going to follow this rule here. So that means we're going to round that 7 up to an 8. So the answer is going to be, it's about 0.8. Okay? If this was 0.74, and when we round it, it would be 0.7. And these squiggly lines basically mean approximately, because we're rounding, so that's what that means. And we don't need to put the 0 after the 8, because that's why we're rounding. Okay, 13. Simplify negative 4.68 divided by negative 0.6. So first off, let's pay attention to the signs. So we are dividing negative divided by negative. So we're going to get a positive quotient. So now let's just ignore the negatives and then go ahead and divide. 4.68, we're going to use long division. That needs to go under the division box, divided by 0.6. Okay, so we need to first move the decimal with the 0.6 one time to make it a whole number. So therefore we need to move it one time here. So the decimal is going to be right there in the quotient. So now we're going to say 46 divided by 6. So let's see. 6 times 8 is 48. So 8 is too big. Let's go with 7. So 7 times 6 is 42. And then we're going to subtract. And then we have 46 minus 42 is 4. And then bring down the 8. And now 6 divides into 48 8 times. 8 times 6 is 48. And then when we subtract, we get a remainder of 0. So the final answer, the quotient, is a positive 7.8. All right, so now simplify. So parentheses 11.1 plus 13.6. All of that is being multiplied by 19.1 minus 14.2. So following order of operations, let's simplify in the parentheses first. So let's start with the first set of parentheses. So I'm going to line it up vertically. 11.1 plus 13.6. So when you're adding decimals, we need to line up the decimal points. So 1 plus 6 is 7. Bring down the decimal. 1 plus 3 is 4. 1 plus 1 is 2. So we're going to have 24.7 times the second set of parentheses. So we have 19.1. Oh, we're subtracting. 14.2. Minus 2 is not going to work, so I'm going to borrow from the 9 and make this 11. So that'll be 11 minus 2, which is 9. 8 minus 4 is 4. Don't forget to bring down that decimal. And then 1 minus 1 is 0. So this is going to be 4.9. So now what I have is 24.7 times 4.9. So now to multiply decimals, we don't have to line up the decimals. So we're going to multiply them like whole numbers. So we're going to have 9 times 7, which is 63. Carry the 6. 9 times 4 is 36. Plus 6 is 42. Carry the 4. 9 times 2 is 18, plus 4, which is 22. Now to multiply the 4 here, I'm going to put a 0 placeholder, and then now we're going to say 7 times 4, which is 28, carry the 2. 4 times 4 is 16, plus 2, which is 18, carry the 1. Then 4 times 2 is 8, plus 1 is 9. So now we're going to add these up. 3 plus 0 is 3. 2 plus 8 is 10. 0, carry the 1. 2 plus 8 is 10, plus that 1 is 11. Carry the 1. Then 1 plus 2 plus 9 is 12. Now, we can't forget those decimals. So we had 2 decimal places. So we're going to move 2 decimal places in the answer. So the final answer is going to be 121.03. Number 15. The fraction 11 over 50 is equivalent to what percent? So we could do this a couple of ways. We could look at it like this. So we have 11 over 50. Well, we know that percent means over 100, a number over 100. So if I were to actually change this 11 over 50 to equal something over 100, then that top number would give us what that percent is. So how do I go, what do I multiply 50 by to get to 100? So what do I multiply 50 by to get 100? I multiply it by 2. So 50 times 2 equals 100. So I'm going to multiply the top by 2. 11 times 2 equals 22. So therefore, 11 over 50 is equal to 22%. The only other way you could do that would be to divide. So we have 11 over 50. That'll be 11 divided by 50. So in order to do that, let's see, this is a decimal. I need to add a 0 in there so I can actually divide 50 into 1110. So 50 divides into 110 2 times, because 2 times 50 is 100. Then if I subtract, I'll have 10. And then I would look at another 0 and bring it down. And so now 50 divides into 100 2 times. 2 times 50 is 100 with a 0 remainder. So we have 0.22. So to change a decimal to a percent, you will multiply that decimal times 100. Or a quick way to do that would be to take the decimal, so if we multiply it by 100, we get 22. Or the shortcut way is to move the decimal 2 places to the right, which would give you 22. So either way, the answer is 22%. I just kind of want to show you the different ways that you could get that answer. Okay, 16. 68% is equivalent to what decimal value? So we have 68%. So we could do a similar thing that I just talked about. So right now 68% is the same thing as saying 68.0%, right? So to change a percent to a decimal, you could just move the decimal 2 places to the left, and we get 0.68. So that would be your answer. Another way would be to take the 68%, that equals 68 over 100, and then actually divide that, okay, which will give you 0.68. Okay, 17. What is 65% of 240? So to find the percent of a number, you want to first change the percent to a decimal, and then you're going to multiply the decimal with the number. So I'm going to change 65% to a decimal. So 65% equals 0.65. And then I'm going to multiply 240 times 0.65. So I'm going to do that by lining up like this. And I'm going to multiply. So first I have 5 times 0, which is 0. 5 times 4, which is 20, carry the 2. 5 times 2 is 10, plus 2 is 12. So my 0 placeholder, and start with the 6. 6 times 0 is 0. 6 times 4 is 24, carry the 2. 6 times 2 is 12, plus 2 is 14. And then we're going to add this up. So we have 0, 0, 6, 5, 1. But I'm not done. Remember, I had 2 decimal places here, so I must move 2 decimal places to get my final answer. So the final answer is going to be 156.00, which we can just say is 156. All right, 18. Molly completed 5/6 of her homework, and Max completed 3/4 of his homework. Who completed the most homework? So we're comparing fractions, and the best way to do that is to create equivalent fractions that have a common denominator. So we want to get the least common denominator between 6 and 4. So let's think of multiples. So multiples of 4, we've got 4, 8, 12, 16, 20, 24, and then multiples of 6 would be 6, 12, 18, 24. So the least common one is actually 12. So why don't we convert 5/6 and 3/4 to be fractions with a common denominator of 12. So how do we do that? Well, 6 times 2 equals 12, so I'm going to multiply the top by 2 as well. So 5/6 is equivalent to 10/12. And then down here at the bottom, 4 times 3 equals 12, so I'm going to multiply the top by 3 as well. So 3/4 is equivalent to 9/12. So now I can compare these fractions better because they have a common denominator. So 10/12 is going to be greater than 9/12. So therefore, 5/6 is greater than 3/4. And so if the question is who completed the most homework, Molly completed 5/6 of her homework, so the answer would be Molly did, because Molly was greater than Max. Okay, 19. So simplify 1/6 plus 9/7. So when we add or subtract fractions, we must have a common denominator. Let's get a common denominator between 6 and 7. And a lot of times the easiest way to do that, it may not be the least common one, but you can get a common one by just multiplying the opposite denominators. So if we multiplied this first fraction by 7/7 and the second fraction by 6/6, which of course is 1, we're not changing the value of this in each, then we'll get two fractions with a common denominator. So first off, that denominator is going to be 6 times 7, which is 42. And now 7 times 1 is 7. 9 times 6 is 54. And so now that we have a common denominator, we're going to keep that denominator the same and then combine the tops. 7 plus 54. So I'm going to add that vertically. 4 plus 7 is 11. Carry the 1. So we have 61/42. And that can't be simplified further. So we are good to go. Okay, so now we're simplifying -17/20 plus 1/12. So what I'm going to do first is let's see what we have with common denominators first. So let's see here. We have 20 and 12. So let's think about the 20. You have 20, 40, 60. 60 would work because 12 times 5 is 60. Yeah. So let's change this to common equivalent fractions with the 60 denominator. So to get 20, to make 20 go to 60, we're going to multiply it by 3. So we're going to multiply 17 times 3. So 3 times 7 is 21, carry the 2. 3 times 1 is 3, plus 2 is 5. So 17 times 3 equals 51. And then 12 times 5 equals 60. So 1 times 5 is 5. So now we can compare these fractions. So I am adding numbers with different signs. So I'm going to subtract and take the sign of the larger number. So ignoring the negative right now, which is bigger, 51 or 5? 51 is. So since that's a negative 51 over 60, I'm going to have a negative answer. Okay? So now I'm going to find the difference between 51 and 5. So the difference between 51 and 5, so 51 minus 5 is going to be 46. 51 minus 5 is 46. We're keeping that same denominator, so the answer is going to be negative 46 over 60, and we can actually simplify that further. Let me not box that in yet. Let me repeat real quick how we got here. So I first got equivalent fractions by getting a common denominator. All right, so I'm using 60 as my common denominator. So to go from 17 over 20 to 51 over 60, I multiply the top and bottom by 3. To get 1/12 to equal 5 over 60, I multiply the top and bottom by 5. So now I can compare, and even if we did it here, ignoring the denominator. So let's say I have negative 51 plus 5. Let's say that's what I'm looking at. Let's ignore the denominator of 60. So I have different signs, so I subtract and take the sign of the larger number. Since 51 is larger than 5, it's going to be a negative, and then 51 minus 5 is 46. So that is why I have negative 46 over 60, because I keep the denominator the same and I combine the top. So actually, let me write that out. I didn't even write that. It's not good. So that's going to be negative 51 plus 5 over 60, which equals negative 46 over 60. And now we need to reduce negative 46 over 60. So we can definitely divide them both by 2. So that would be negative 23 over 30. And then that would be my final answer for that problem. And notice if you're doing your final exam review, it's going to tell you to write it as a reduced fraction. All right? So pay attention to those instructions, because if you put negative 46 over 60, you won't get the answer correct because it's asking for a reduced fraction. Okay, so now simplify. Negative 2/5 divided by negative 4/9. So remember, when you divide or multiply same signs, the answer will be positive. So this is going to be a positive quotient. Now when you divide fractions, you do what I like to call keep, change, flip, or you're multiplying by the reciprocal. So that means you keep the first fraction the same. We're going to change division into multiplication and then flip the second fraction. So it'll be a negative 9 over 4. So now we can multiply straight across and then simplify. So remember, a negative times a negative is a positive. So we have 2 times 9 over 5 times 4. So that's 18 divided by 20. And then we can divide both of these by 2 to get a reduced fraction. That's going to give me 9 divided by 10. So 9/10 will be my final answer. 22. Simplify. 7 over 9 plus 1 over 3 times 3 over 2. So we want to follow order of operations here. And I don't have any parentheses, I don't have exponents, but I do have multiplication and I have some addition. So I want to do that multiplication first. So I'm going to multiply here. So 1/3 times 3 over 2. So you can actually cancel out these common factors, and I'm just going to be left with 1 over 2. So I have 7 over 9 plus 1 over 2. So now to add these fractions, I have to get a common denominator. So I have 9 and 2, I can get a common denominator of 18 by multiplying the fractions by the other denominator. So if I multiply the first fraction by 2 at the top and bottom, I'm going to have 14 over 8. And then if I multiply the second fraction by 9 at the top and bottom, I'll have 9 over 18. And so now that I have that common denominator, I'm going to keep that denominator the same and then combine the top, 14 plus 9. And then 14 plus 9 is going to be 23. So I have 23 over 18. And then I can't reduce that further, so that's my final answer. Okay, simplify 8 over 3 minus 1/4 squared. So again, referencing that order of operations. You're going to use order of operations pretty much anytime you're in a math class. So we have parentheses, but in the parentheses, we just have a fraction. So there's nothing we can do to simplify 1/4 further. The next step would be to look at the exponents. So we do have exponents here. So 1/4 squared is the same thing as 1/4 times 1/4, which will be 1 times 1 over 4 times 4, which would equal 1 over 16. So 1/4 squared equals 1 over 16. So I'm going to bring down the 8 over 3 minus 1 over 16. And so now I want to get common denominators so I can subtract these fractions. So I have 3 and 16. Let's see here. So let me think of multiples of 16. So I have 16. 16 times 2 is 32. 16 times 3, 48. And 16 times 4 is 64. And then multiples of 3, 3, 6, 9, 12, 15, 18, 21. Kind of keeps going on. But actually, we're going to end up getting 48 because I can divide 3 into 48. That gives me 16. 48 is going to be my common denominator. And to be honest with you, again, if you couldn't think of a least common denominator, you could just multiply the denominators together to get a common denominator. So if I want to use 48 as my common denominator, I'm going to multiply the first fraction by 16 to top and bottom. So 16 times 8. 8 times 6 is 48. Carry the 4. 8 times 1 is 8 plus 4 is 12. So 128 over 48 minus, multiplied by the 3 over 48. Now that I have that common denominator, I'm going to keep that denominator and then subtract 128 minus 3, which will give me 125 over 48. And then when you're trying to think about if you can reduce the fraction, focus on the smaller number. So think about all of the factors for the smaller number, which in this case is the 48. And if any of those factors, like 4, 12, 2, can be divided into 125, then you would want to reduce it. But in this case, you can't reduce it further, so your final answer is 125 over 48. Okay, 24. Negative 2 over 9 minus negative 1/5 plus 1/3. So we're going to work within the parentheses first. And so to add these fractions, we have to get a common denominator. So I'm going to have, let's use 15 because 5 times 3 is 15. So I'm going to multiply the first fraction by 3 over 3 and the second fraction by 5 over 5. So I'm going to have a negative 3 over 15 plus positive 5 over 15. So that will end up being negative 3 plus 5 over 15. So negative 3 plus 5, different signs. We subtract, take the sign of the larger number. That's going to be positive 2 over 15. So this is going to go in that box. So now let's go back to my original problem. Negative 2 over 9 minus 2 over 15. So now I want to get a common denominator between 9 and 15. And I'm not going to just multiply 9 times 15 because I do know that 45 is a multiple of 15 and 45 is also a multiple of 9. So I'm going to use 45. So to go from 9 to 45, I multiply it by 5. So I'll get negative 10 over 45. And then to go from 15 to 45, I multiply it by 3. So I have negative 6 over 45. So now I have combined the top, negative 10 minus 6 all over 45. So I have the same signs here, negative 10, negative 6. So I add and keep the sign. So it's going to be a negative 16 over 45. And then if I think of my factors for 16, it'll be 1, 4, 8, 16. None of those numbers can be divided into 45, so this is going to be my final answer. Okay, 25. Simplify. 11 minus 6 times y plus 10. So we want to simplify this by first taking this negative 6 and distributing it inside this parentheses. Because in the parentheses y plus 10, we can't simplify that. So I'm going to bring down that 11 and then negative 6. Let me just write it all out. Times y. And then I have negative 6 times 10. So now that's going to be 11. Negative 6 times y is negative 6y. And negative 6 times 10 is negative 60. And now I want to combine like terms. The like terms I have here are my constants. This 11 and this minus 60. So I actually have 11 minus 60 minus 6y. So when I combine 11 minus 60, so I can think of that as changing that to adding the opposite. 11 plus negative 60. So when I have different signs, I subtract and take the sign of a larger number. So the larger number is 60 here, so it's going to be a negative 60 minus 11. 60 minus 10 is 50, so 60 minus 11 will be 49. So I have negative 49, and then bring down that minus 6y. So I can write that as negative 49 minus 6y, or negative 6y minus 49. Both of these are okay answers. I might say yes, we'll accept both of those. 26. Solve the equation. So 19 equals 10 plus x. So when you're solving an equation, the goal is to get the variable by itself on one side of the equal sign. So here's my equal sign here. So on the left-hand side of this equal sign, I have 19. On the right side, I have 10 plus x. So I want this x on the right to be by itself. So I want to move that 10. So to move the 10, that's a positive 10. So I want to subtract 10. So 10 minus 10 will be 0. It'll go away. But this is an equation, so I have to keep my equation balanced. So if I subtract 10 on the right, I have to subtract 10 on the left. So now on the left, I have 19 minus 10, which is 9, equals bring down that x. So I can write that the other way and say, so x equals 9. Then I can always check my answer in any solution, any equation that I solve, by plugging x equals 9 back into your equation. So it was 19 equals 10 plus x. So I'm going to take this x equals 9 and plug it in for x. So I have 19 equals 10 plus 9. And 10 plus 9 is 19. So therefore, I know I have the correct answer of x equals 9. Okay, 27, solve for x. So again, I want to get the variable by itself. So to start that process, let me get the term with the variable by itself. Let's get that negative 2x by itself. So I have this plus 1 on the left side of the equal sign here. So I want to get rid of that plus 1. So to make plus 1 go away, I'm going to subtract 1. But it's an equation. I have to keep my equation balanced. So if I subtract 1 from the left, I have to subtract 1 from the right. So now I'm going to bring down my negative 2x. 1 minus 1 cancels out, equals 9 minus 1 is 8. So now I have negative 2x equals 8. So I want to get x by itself. I don't want to have a negative 2 multiplied in front of it. I just want x to be by itself. So I want to undo or do the opposite of this multiplication that's happening here at negative 2x. Because negative 2x is the same thing as negative 2 times x. So if I divide by negative 2, that will leave me with just x. That's what I want. But I can't divide by negative 2 on the left and not divide by negative 2 on the right. Because remember, that equal sign is like a balance. That equation has to be balanced. Okay? So now 8 divided by negative 2, I'm dividing different signs. I'm going to have a negative answer, and the answer will be negative 4. And on the left, that negative 2 divided by negative 2 canceled out. So the final answer would be x equals negative 4. And so remember, we can always check our answer. So we had negative 2x plus 1 equals 9. So let's plug in negative 4 in for x. So I have negative 2 times negative 4 plus 1 equals 9. So negative 2 times negative 4 is a positive 8 plus 1 equals 9. 8 plus 1 is 9, which equals 9, and that's correct. So I know that x equals negative 4 is in fact my correct answer. Okay, 28. Evaluate negative 4m squared for m equals negative 4. So this is asking us to take negative 4, which is equal to m, and plug it in everywhere you see m in the expression here. So that's going to be negative 4 times m is going to be replaced with negative 4 squared. So we're going to follow our order of operations, and we are going to evaluate the exponents first. So I have negative 4 squared. That is the same thing as negative 4 times negative 4, which is positive 16. So I have negative 4 times 16. And then now, negative 4 times 16, I'm multiplying different signs. I'm going to have a negative, and then I want to take 16 times 4. 6 times 4 is 24, carry the 2. 4 times 1 is 4, plus 2 is 6, so the answer is going to be negative 64. Okay, 29. Find the area of a rectangle. To find the area of a rectangle, we use the formula A equals length times width. If the length is 15 feet, so So if L equals 15 feet and the width equals 6 feet, so W equals 6 feet, find the area of the rectangle. So just so we know what we're talking about, I'm going to just kind of draw it out. So the length they're saying is 15 feet and the width is 6 feet. And so the area formula is length times width for a rectangle. We basically want to find 15 times 6. So then if I do 15 times 6, 6 times 5 is 30, carry the 3. 6 times 1 is 6, plus 3 is 9. And now, since we did feet times feet, the answer is going to be 90 feet squared. That's going to be the area of that rectangle. All right, number 30. Translate the following expression into an algebraic expression. 12 more than x. So 12 more than x would be 12 plus x. You could also, because addition is commutative, say x plus 12. Both answers would work for this problem. So you want to pay attention to those translated expressions, like those phrases like more than, less than, product of, things like that. So definitely reference those phrases and be familiar with them for a question like this. Okay, 31. Nina and Samantha were putting up some fencing across their ranch. They know that for every 144 feet of fencing, they will need 8 posts to hold it up. Which of the following proportions is set up correctly to find the number of posts it will take to put up 216 feet of fencing? So the important thing with setting up a proportion is that your units have to match. So in this case, we are comparing fencing, feet of fencing compared to the number of posts, right? So like if you have to decide whether you're going to do, is your ratio going to be feet over posts or posts over feet. That's really what you're looking at. It has to be like aligned, both of them. So let's just look at our options. This will be a multiple choice problem on the final. Let's look at option A. So we have 144 over 216. Or you could say posts over posts. It'll have to be equal to the same feet over feet. And then I like to use colors for problems like this. I'm going to do that here. So, for every 144 feet of fencing, you need 8 posts to hold it up. And then how many, find the number of posts, that'll be x, for 216 feet of fencing. So let's see how these proportions are set up and pick the right one. So for letter A, you've got 144 over 216 equals x. In this case, the x is the number of posts. So this will be a green over 8. That's the yellow. So you see how they're not lined up? It should be either yellow over yellow, green over green. So since this is not aligned, this is not going to work. Let's look at the next one. So we have x over 144. That'll be green over yellow equals yellow over green. This is another example where it's not lined up, because this is also x is the number of posts over fencing for another scenario equals 8 the number of posts over a totally different scenario, so this would not work. Let's look at the third one. So we have 8 posts for every 144 feet of fencing equal to X posts for every 216 feet of fencing. You see how that's lined up properly? That's probably the answer. Just so that we're clear, let's do the next one. So even though this is 144 over 8, which is going to be yellow over yellow, it's equal to X over 216. So basically, this is going to be posts over feet. This last one is not posts over feet. The first one is feet over posts, and the second one is posts over feet. So that's why that one's not going to work. So the answer here will be C. Okay? So you want to make sure your proportion units line up across each ratio. Okay, 32. At the beginning of a basketball season, the Panthers won 7 games out of 12 games played. At this rate, how many games will they win in a normal 48-game season? So we can set up our proportion to be games won over games played. So the first one would be 7 games won out of 12 games played. At this rate, how many games will they win? So how many games will they win? We don't know, over 48 games. So let's see, we have 7 over 12 equals X over 48. So let's get X by itself by multiplying the right side by 48 and the left side by 48. So on the right, 48 will cancel, and I'll just have X equals, and so I have 48 times 7 over 12. Well, I can reduce 48 over 12. I can divide them both by 12. So 12 goes into 48 4 times, and 12 goes into 12 1 time. So that will actually just be 4 times 7, which is 28, equals X. Okay? So it would be 28 games. Okay, 33. Find the area of a square with sides 8 meters long. So if we have a square has all equal sides. Okay? So this would be 8 meters. All 4 sides would be 8 meters. The area of a square would be S squared, or the sides squared. So that would be 8 squared, which is 8 times 8, which equals 64. And since the units were meters, it's going to be 64 meters squared, or 64 meters squared. 34. Find the area of the circle pictured below. Use 3.14 for pi. So the area of a circle is pi r squared. This picture is telling us that the radius is 8 inches. So we're going to use 3.14 for pi, so it's going to be 3.14 times 8 squared. So 8 squared is 64, so 3.14 times 64. Let's do that here on the side. 3.14 times 64. So 4 times 4 is 16, carry the 1. 4 times 1 is 4, plus 1 is 5. 4 times 3 is 12. Put a 0 placeholder. 6 times 4 is 24, carry the 2. 6 times 1 is 6, plus 2 is 8. And 6 times 3 is 18. They're going to add it up. So 6 plus 0 is 6. 5 plus 4 is 9. 2 plus 8 is 10. Carry the 1. 1 plus 1 plus 8 is 10. Carry the 1. 2. But remember, I had 2 decimal places, so that's going to move that decimal here. So I end up with 200.96, and then it said round to the nearest tenth. So the nearest tenth would be here. I'm going to look to the right. That's a 6. So that means I would round this 9 up. And if I round the 9 up, that's going to force us to then round the next number. So it's going to end up being 201. That's going to be our area, 201 square inches. And then finally, that's up there, convert the measurement. So we have 13 gallons. We want to convert that into pints, and you will be provided with a conversion table. So we want to use what we're given to go from gallons to pints. So I've got gallons to quarts and then quarts to pints. I'm going to use this information here. So I'm going to start with 13 gallons. And I'm going to multiply that by some ratio to get rid of the gallons. And I want to convert them to quarts. Okay, so what do I know about, so why did I put the gallons on the bottom? I put the gallons on the bottom because when I multiply, the gallons will cancel out and I'll end up with quarts. So let's see, I know that 4 quarts equals 1 gallon. All right, but I want to end up with pints. So I'm going to multiply that by something where I have quarts on the bottom and pints at the top. All right, that's going to come from this information here. So what do I know about pints and quarts? I know that 4 pints equals 1 quart. So let's see what's going to happen here. So I have 13 times 4 times 4 over 1 times 1. And what units am I going to end up with? Well, gallons over gallons canceled out. Quarts over quarts canceled out. I'm left with pints, and that's what I wanted. So I need to do 13 times 4 times 4. And so multiplication is commutative, so I can actually do 4 times 4, so that's going to be 13 times 16. And let's see what that would be. 13 times 16. So 13 times 16. 3 times 6 is 18, carry the 1. 6 times 1 is 6, plus 1 is 7. Put a 0 placeholder. And 1 times 3 is 3, 1 times 1 is 1, and we're going to add that up. So we have 8, 0, carry the 1, 2. 208 pints. 208 pints. You know what? I typed those conversions wrong. I apologize. This should actually be two pints equals 1 quart. So this number should be a 2. That means this would be a 2, and this would be a 2. So that's going to change my answer here. Sorry about that. I just looked at my answer key and realized when I was typing this review that I typed the wrong number here. So it's 2 pints equals 1 quart. So now, let's see. So I have 13 times 8. So 13 times 8. 8 times 3 is 24. Carry the 2. 8 times 1 is 8. Plus 2 is 10. The answer is 104 pints. But the main thing here is lining up your units so that what you want to cancel out to the top and the bottom, and what you want to be left with is the last unit standing at the top. All right, so that is a final exam review worked out from beginning to end. So it is my advice to use this final exam review in your course and practice as many times as possible so that the questions get more and more familiar to you, and you do want to do the final exam review for a lab grade, and you want to scan your written work for your final answers for the final exam review. So if you have any questions about your final exam, please contact your professor. The last day to take the final exam is going to be on Wednesday, February 27th. And it's the very last day to take the final exam in the testing center. So I hope you guys study hard. Come to the depot for any questions. We have great tutors there to help you. And I will see you guys online. Thanks so much.